So I'm going to try to teach you about fats completely on video, which is crazy, but everything about this year is crazy. So here we go. I'm going to use my giant whiteboard that's on my dining room table. So fats are part of a group of biomolecules called lipids. And lipids are things that don't dissolve in water. So they're hydrophobic. So fats are things that we use for three purposes. We use them for insulation, so we don't get cold. We use them for energy, especially long-term energy. And we use them for cushioning, especially around our organs. So the main thing that, of course, that you remember for purpose of fat is for energy. Now, the chemical name for fat is called a triglyceride. And triglycerides have three molecules called fatty acids. And those fatty acids are connected to one glycerol. So I'm going to draw some of the fatty acids, and then we're going to be mainly talking about different types of fatty acids and how some of them are healthy to have in your diet and some of them are not healthy to have in your diet. And you're going to learn how to draw them and how to build them. Okay, so I'm going to erase this. And I'm going to draw a fatty acid. Okay, so we were just learning, let me just review a tiny bit. We were learning before about carbohydrates. If you remember, they mainly had this functional group called a hydroxyl, which is an OH group on it. And those hydroxyls made it really polar and soluble in water. And if you remember from your little lab, you could put a lot of sugar in water. So these are very polar. Fatty acids are very non-polar because, here's a fatty acid, they have a whole bunch of just hydrogen and carbon, and all of those bonds are non-polar. They have a tiny bit of polarity here with the functional group, which is called the carboxyl groups. So they do have a tiny polar end, but a huge section that's non-polar. So I'll show you how to draw a fatty acid. Okay, so you can start with the carboxyl. So carboxyl is a carbon double bonded to an oxygen with a OH on it. That's called a carboxyl. And a carboxyl group is an acid. And it's an acid because this double bond can sometimes move over here and kick that hydrogen off. So if this double bond moves over, that's going to make this hydrogen go away. And anything that donates protons is an acid. Okay, so that's why it's an acid. Okay, then what you do to draw a fatty acid is you draw the carbons, the carbon, hydrogen, carbon, hydrogen, carbon, hydrogen kind of thing, but you don't have to draw all the C's and C's and C's. You can just draw zigzags. So this is the number one carbon, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the 10th carbon here. So let me show you what that looks like with this structure. Here's the carboxyl group, right? Here's the double bond O and the OH, and here's the zigzag. Ziggity zaggity, ziggity zaggity, ziggity zaggity, ziggity. There you go. So there, all you're having to show is this da dun 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 da dun. And so you don't have to draw anything else. That's just understood to be carbon, 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 and all of this hydrogen. Okay, so this is the hydrocarbon tail. Okay? So this particular fatty acid, we say that it is saturated because the fatty acid itself, the tail of it, doesn't have any double bonds. So everywhere there could be a hydrogen, there is a hydrogen. And so it's called saturated because it's saturated with hydrogen. So if you have no double bonds, now I'm not talking about this double bond. That's on every fatty acid because that's on the carboxyl group. No double bonds in the hydrocarbon chain. Then it's called saturated. So fats that contain saturated fatty acids tend to be hard at room temperature or solid at room temperature. And that's because these single bonds have a lot of flexibility, they can get more compact. And so they can be more solid at room temperature. So fats that have a lot of saturated fatty acids include animal fats. So like butter or lard or milk fat or animal fat will be saturated like this. The only plant fat that is saturated are tropical fats, tropical oils. So like coconut oil or palm oil will also be saturated like this, and they'll be solid at room temperature. So fats and oils are really the same. They're like the common names for triglycerides. Oils, you tend to say a triglyceride is an oil if it's liquid at room temperature, and you say it's a fat if it's solid at room temperature, although a lot of people say it's coconut oil. I guess it depends how warm your room temperature is, because in the tropics, coconut oil is liquid. So that's the saturated fatty acid. Now, in your diet, you don't want to have too many of these. They're not terrible for you, but it's obviously not great to have a lot of saturated fat in your diet. Okay, so that's a saturated fatty acid. So the next one I'm going to show you is, I think I'm going to go to the other extreme and get a very, very, very unsaturated fatty acid. So I'm going to have you guys building these later. Okay, so this guy's really long and crazy shape. So this is a omega-3 fatty acid, and it's found in a lot of fish oils. So I guess the animal fat that isn't saturated would be fish fat. So I guess when I'm saying animal fat, I'm talking about mammals. So anyway, here's the carboxyl group, the C-double-bond-O-OH. Remember, you have to have the carboxyl group to be a fatty acid. But I want you to notice all the double bonds that are present in this fatty acid, lots of them. And the reason why it's called omega-3 is if you look at the tail end and you go back 1, 2, 3 to the third carbon, that's where you hit the first double bond. So omega is the end of the Greek alphabet, so this is the end of the fatty acid. This is the head end, and this is the tail end. So omega minus 3, or omega-3, is where you find the first double bond. So now, omega-3 fatty acids usually have a whole bunch of other double bonds. So this one has 6 double bonds. They're also usually really long. This has 22 carbons. So I'm going to show you how to draw this. Okay, so I'm going to put it up there. And we're going to draw it from the tail end forward. Okay, so you start at the tail end. That's going to be your first carbon. You go 1, 1, 2, 3. So when you're at your third carbon, this is 1, 2, 3, you're going to put your first double bond. And then this would be the fourth, 5, 6, and then put another double bond, because it's pretty much every other is the double bonds. So 1, 2, 3, 4, 5, 6, 7, 8, 9, let's put another one, 10, we'll lose track again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Okay. And then I'll put my C double bond O, OH there. So this is an omega 3. 1, 2, 3. So you can write omega minus 3. Or sometimes they write it this way, omega minus 3. And then you want to say how long this is. So you're going to say 22, that's how many carbons. And then you put a colon and you put how many double bonds you have. 1, 2, 3, 4, 5, 6. Okay, so this is a way of telling you what kind of fatty acid this is. This is a 22,6 omega-3 fatty acid. This would be found in fish oil or flaxseed oil, or sometimes some nut oils have omega-3s like walnut oil. Okay, and these fatty acids are super good for you, like the best thing in the world. So they help reduce inflammation, they help your skin, they help your brain, they help with ADD, they help with depression, they help with heart disease, they prevent heart disease. They're like the best damn things you could ever eat. So if you don't like to take fish oil supplements and you don't like fish, then you can eat flaxseed. You can grind it up and add it to your cereal or your yogurt or your smoothies. Or instead of fish oil, you can try krill oil, which are smaller caplets and they don't taste as fishy. And as a little hint, if you want to take fish oil, you can freeze the capsules and they're easier to swallow and they don't taste like fish. And they actually last longer that way too. Okay, or you can eat lots and lots of walnuts. All right, so these are your healthiest oils you could eat. Of course, you're not going to like cook in these oils or bake with these oils, and you don't need that much. You need about 1 gram a day. So if you like fish, especially raw fish, you're good to go. Okay, so that's your omega-3 fatty acid. So far we've done saturated fatty acid and omega-3 unsaturated fatty acid. Okay, the next one I'm going to show you is an omega-9, which is this guy. Let's move these out of the way so they're not confusing the picture here. Okay, so again, here's your fatty acid. Here's the carboxyl group, and here's the fatty acid tail. If you look at the end and you go back 1, 2, 3, 4, 5, 6, 7, 8, 9, the first double bond is 9 from the end, so this is an omega-9. There's only one double bond here, so this is called a monounsaturated fatty acid. So this is going to be omega minus 9 monounsaturated. Remember, it's unsaturated because you could get more hydrogen on here if you broke this double bond. Also, the one before, I forgot to tell you, that would be a polyunsaturated fatty acid because it has more than one double bond. So this is an omega-9 monounsaturated. This is called linoleic acid. That's very different from lineic acid, or sometimes it's called oleic acid. Pretty sure they're the same thing. And this is found in olive oil and in avocado oil and in almond oil, and peanut oil. Okay, and all of those oils are good to use in cooking. So just for those of you who are cooks, olive oil is great for sauteing as long as it's not super hot, as long as you're not like deep frying or heating at a really hot temperature. Avocado oil tends to be better, or peanut oil. I guess you can't see the word peanut oil. Peanut oil and avocado oil are better for high heat. I don't know if anybody cooks with almond oil. Okay, walnut oil is really good too. that has both oleic acid and omega-3 fatty acids in it. So that's good on salads as your salad dressing too. Okay, so omega-9s, monounsaturated, are good fatty acids to eat. They're the ones you want to buy at the grocery store. So you do not want to buy vegetable oil or corn oil or soybean oil or safflower oil. You're going to see that's the next type of fatty acid that is not so great for you. So omega-9s are good. So to draw an omega-9, again, you would start at the end and you go 1, 2, 3, 4, 5, 6, 7, 8, 9. Make your double bond. And then this, I believe, has 18 altogether. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And here's your C double bond O, OH. Okay, so that would be your omega-9 monounsaturated fatty acid. Okay. Okay, two more to show you. Okay. This guy, here's your carboxyl again. You can see he has 2 double bonds. So it's polyunsaturated. And this one's an omega-6. 1, 2, 3, 4, 5, 6. 6 carbon is where your double bond is. So this is omega-6 polyunsaturated fatty acid. This is going to be found in corn oil and soybean oil and safflower oil. And although this isn't a terrible fatty acid for you in your diet, we have so much of it in our diets because we have so much soybean oil and corn oil that we use. Those are the cheapest oils, so those are what are in all processed foods, what all foods are fried in. We just get a lot of this fatty acid, and so because we have so much of it, it becomes, it causes inflammation, and it can be a root cause of a lot of issues, including heart disease, cancer, and if you're talking about something like COVID-19 where you have inflammation as part of the disease progression, these oils would be bad because it would contribute. It would just raise your level of inflammation so that you would start at that high level of inflammation and go forward. So it wouldn't be a great thing to eat. So you want to try to reduce the amount of these omega-6 polyunsaturated fatty acids, or linoleic acid is what this is. So just look when you're looking at your foods. You want to, especially foods that are oily and fatty and have a lot of fat in them, you want to make sure they don't have very much corn, soybean oil, or safflower oil. Those are all not great oils. So if you go in your pantry and you find something called vegetable oil, you don't want to use that for cooking or frying. You want to use the omega-9s, which are the avocado, olive oil. Canola oil is actually the cheapest oil that's not so bad for you. So canola oils have omega-9s as well. Okay, the last type of oil I'm going to show you, oh actually I'm going to show you how to draw this. Okay, so this is an omega-6. So we start at the end, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Here's your double bond, 7, 8, 9, 10, 11, 12, 13, 14. Make another double bond, 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I made this 16:2 omega minus 6 polyunsaturated. But I think this actually has 18. But more or less you get the idea. I just add another 2 carbons. So let me tell you a little story about trans fats. So trans fats are the worst fats of all. You can't get a worse fat than a trans fat. So trans fats are bad. Very bad. And the reason we even have trans fats aren't really found in nature that much. But if you take oil like this, so this oil would be liquid at room temperature, like corn oil, and you want to make it into a solid. So back in the day when World War II was happening and butter was at a shortage, they made butter out of corn oil. And so what they did was they took the corn oil fatty acids and they added hydrogen to it. So to hydrogenate the oil, what happens is, let me get some hydrogen and some bonds here. You bubble hydrogen gas through this oil, and it breaks some of the double bonds completely. So let's say this double bond got broken and made into a single bond. And so hydrogen would be added because you're going to have to add some more hydrogen to this. But some of the double bonds wouldn't get broken so much. They would just change from cis to trans. So let me show you what that means. Okay, so this double bond got broken, and now it's a single bond. But this double bond over here, when you hydrogenate it, it's possible that it can go from cis to trans. Now, so let me show you what cis and trans means. If you look at the double bond like this, do you see how the hydrogens are on the same side and the chains are on the same side? So cis means same, like cisgender. It means they're the same. So this is a cis double bond. But if it gets changed to trans, what happens is the hydrogens will be on opposite sides of the double bond. So this bond will break and it switches. So the hydrogen is over here now and the double bond is here now. And you see how it completely changes the shape of the fat. So now you see the double bond here. The hydrogens are on opposite sides. That's a trans double bond. So when you hydrogenate an oil, you break some of the double bonds and that makes it more solid, but you inadvertently make some of these double bonds, and these are not normal shape. Okay? And this double bond, so fatty acids are incorporated into our cell membranes as phospholipids, which we're going to learn about later. And this shape is not the right shape for a phospholipid, and it causes the cell membrane to not be as permeable to oxygen. It changes the fluidity of the membrane. It just makes cells unhealthy, and it also really increases inflammation in the body. And all the inflammatory markers go way up, and you get cell damage, and you get artery damage, kind of like all the bad things that happen when someone gets really sick with COVID. Trans fats cause inflammation. You don't want trans fats. So what you want to do when you're looking at your food to buy, you want to look for hydrogenated oil. If you see the words hydrogenated oil or partially hydrogenated oil, you don't want that. Okay, so the foods that tend to be higher in hydrogenated oil are peanut butter, not the natural kind, but the like Jif or Skippy kind. They have hydrogenated oil, generally. And coffee creamers. Now, not like half and half, but I'm talking about like Coffee Mate or whatever. They are really high in hydrogenated oils. And then Crisco, or vegetable shortening, is basically solid trans fat. You don't want that. So those are the three kinds of foods to avoid. Most companies have changed their, because people are looking for foods that don't have trans fat. They've changed it so that they use coconut oil and palm oil instead of hydrogenated oil. So it's better now than it used to be. But these are the three foods you kind of want to make sure that you avoid. You get a coffee creamer that doesn't have any trans fat in it. Now, you also have to be careful with the way that they label it, because a lot of times they shrink the serving size so small that if it has less than 0.5 grams, they can round that down to 0. So if they make the serving size really small and you'll have like 0.4 grams of trans fat per serving, then they can just say that that's 0, even though it's not. Nobody puts a teaspoon of coffee creamer in their coffee, so it's just, I think it's just misinformation. Okay, so those are the different kinds of fatty acids and which ones are bad and which ones are good for you. So let me recap. Good fatty acids are the omega-3s, which are like fish oil, and the omega-9 monounsaturated, so like oleic acid, and that's like olive oil. Those are the good ones. You obviously aren't going to cook with fish oil, but if you're going to cook with an oil, you're going to cook with olive oil or peanut oil. Sorry, can't see that. Or you can cook with avocado oil. Those are all omega-9s. The bad ones are trans fats. This is bad. And so that's hydrogenated. And saturated fats, which are the animal fats like dairy products and meats like beef and pork and chicken fat. The one saturated fat that is not so bad is coconut oil. And they used to think that coconut oil was like the bomb diggity, but now they're realizing it's not super great. I think it's fine in small amounts. So now I'm going to just show you how you make a triglyceride from the 3 fatty acids and the glycerol. Okay, so I'm going to take 3 fatty acids. If they don't have to be the same, so I'm just going to take any 3 here. They don't tend to be as different as these 3 are, but we're going to take 3 fatty acids, and then I'm going to show you what a glycerol looks like. Okay, so a glycerol has 3 hydroxyl groups on it. So it's a 3-carbon molecule that has 3 hydroxyls. Okay, so I need some hydrogens here. Okay, notice that I have 3 carbons and 3 hydroxyls. So here's 1 hydroxyl here. This one needs a hydrogen on the end of it. And this one needs a hydrogen on the end of it. Okay, so that's glycerol. The way you draw that is like this. COH, COH, COH. And then these are hydrogens. That's glycerol. Okay, so there it is here. So attached to each one of these hydroxyl groups is going to be the fatty acid. And we're going to do dehydration synthesis. So I'm going to take 1 fatty acid here, and I'm going to remove water. So dehydration synthesis is you remove water. So I'm going to take 1 OH off this guy, and a hydrogen off his little nose here to make water. And then I'm going to connect this up. Okay, so I connected 1 fatty acid. So now I'm going to do the same thing to this carbon, this hydroxyl group. So I take the next fatty acid and I rip off an OH and an H and I connect them and I make another water. There's my water, and there's the second fatty acid. So now you can see I have 2 fatty acids attached here. And then I'll do that same thing with the third one. I'm going to take an OH off here and an H off here and make the third water and attach that. So now this is crazy, but now here's my triglyceride with my 3 waters. So let me show you how you do that with a 2-dimensional drawing. Okay, so here's my glycerol again. Okay, so if I had a fatty acid like this, and I had the tail, I'll take this off, this water off. And here's another fatty acid with the tail, and I take this water off. And here's another fatty acid with the tail, and I take this water off. And if I remove those waters, I'm connecting that together like this. There. And now I have a triglyceride. So these fatty acids don't actually have to have the exact same double bonds or the exact same length. But this would be a fat or an oil. So fats and oils are made up of fatty acids connected to glycerol. And that makes this a triglyceride. And that'll be a fat if it's solid at room temperature, and it'll be an oil if it's liquid at room temperature. Okay, so I'm going to have you guys build some fatty acids and draw them for your activity. So I'm going to be having you take your molecular sets and making short fatty acid chains of different types.